let's start our codes from this presentation. And first I will write down the codes that we are going to study. The first one is your BCD, or it is also called as 8421 code. We will complete this BCD in this lecture. The second one is your gray code. The third one is your access 3 code. And the fourth one is your 2421 code. We will see what are these and also see some of the properties that are important while solving the questions for this particular code. So without wasting any time, let us start the first one, that is our BCD code. Okay, now here your BCD, it stands for binary coded decimal. Okay, this BCD is an abbreviation for your binary coded decimal. It is also called as 8421 code. Why it is called as 8421 code? Because of the weights. Okay, we will see why it is called as 8421. So as it is the binary coded for the decimal one, so we will first write the decimal and then code it into the binary, or we can say that BCD. So the decimal numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so by using this 8421, let's see how we can code it. So this is 8421. This is actually the weight of the different bits. The first bit is having the weight of 1, the second bit is having the weight of 2, the third bit is having the weight of 4, and similarly the fourth bit is having the weight of 8. If you have already learned from my previous lectures, then you might knowing what is this weight. So let's start. If you want 0, then you have to make 0. The 4 zeros, you have to make all the 4 bits as 0. Okay, and if you want to make 1, then you have to make the first 3 bits 0 and make the last bit 1. Okay, similarly if you want 2, then you are having 0, 1, 0, because if it is 1, we are having 2. Similarly for 3, you want 0, 0, 1, 1. 2 plus 1 is your 3, and 4 will be 0, 1, 0, 0. Okay, and 5 is your 0, 1, 0, 1. 6 is your 0, 1, 1, 6. 4 plus 2 is your 6. 7 is your 0, 1, 1, 1. 8 is your 1, 0, 0, 0. And the last one, 9, is your 1, 0, 1. So this whole set of codes is called as BCD, binary coded decimal, because we have coded these binary numbers, the decimal numbers into the binary, the 4-bit binary. We require only 4-bit binary to represent up to 9. Okay, so let us see some of the properties of this code. The first one is it is weighted code. Okay, why it is weighted code? Because there is a weight of each position. If you are talking about the access 3 code or gray code, they are not weighted code, they are unweighted code. We will see why we call them unweighted code, and there is nothing special to see in them, because by the name it is very clear that the positions do not have weight. Like here position is having weight, but in that case the position do not have weight, so not a very big thing. Okay, the another point is that it is also called as 8421 code. Okay, this is something that I have already explained, and in this code all the decimal numbers, that is 0 to 9, is represented by 4-bit binary numbers. Okay, now there is one more thing that we have to see is what happens for the other decimal numbers, or you can say the combination of the two decimal numbers from this 0 to 1, like 1 0, 1 1, 1 2, 1 3, 1 4 and 1 5. As there are 4 bits involved, so by using these 4 bits we can represent from 0 to 15. So in this cases, from here to here, it is considered as the case of don't care. Okay, or you can write it as invalid. Don't cares. This don't cares is very useful when you solve the K map. As we have not completed the K map, that's why we don't talk much about it. So this is the invalid, you can say, numbers. If you want to represent this 10, 1 1, 1 2, 1 3, 1 4 and 1 5 in BCD, we have to follow something else. Okay, and this is the next thing that we are going to do. So let's put it as one example. The example says that you have to represent, or you can say convert, the given decimal numbers to BCD. Convert given decimal numbers to BCD. The first one is your 35, the second one is 174, the third one is 2479. So let's see how it is done. 3 5. By using binary numbers you can definitely represent 35. Okay, but if you want to represent it by BCD, you have to do something different than usual. You have to take this first number 3 and represent it in BCD, and 3 is represented in BCD by 0011. Okay, so it will be 0011. Now 5 is represented by 0101. You can see from the above table. So in BCD it can be written as 00110101. Okay, this is how we represent a number in BCD. Similarly, let's solve the rest of the 174. So this 1 is represented as 0001, 7 as 0111, this 4 as 0100. So it is something 0001, 0111 and 0100. This is in BCD. These two are in BCD. Similarly, we can write the last number, that is 2479 in BCD as the 2 is represented as 0010, the 4 is represented as 0100, the 7 is represented as 0111 and the 9 is represented as 1001. Okay, so this is how we convert any number, any decimal number into BCD. Now let's see that how this 35 can be written in binary. In binary only. Remember, this is not BCD, it is simple binary. So you know how to find it. I can write it directly, but I'm doing it by the procedure. So 2 goes 1 6, not 6, is 7, 17 times, and the remainder will be 1. Similarly, for the 17 it goes 8 times with remainder 1. This 8 goes 4 times with remainder 0. This is 2 0 2 1 0. So this is your MSB and this is your LSB. So it is 1 0 0 0 1 1. Okay, so this is in binary and this one is in your BCD, and both of them are not same. Okay, so this is the difference when you write a given decimal number in a BCD. This is the way to write it. You have to select the numbers individually and write it in BCD, and then write them collectively. On the other hand, if you want to write them in binary, you have to follow this procedure that we have already discussed in decimal to binary conversions. So this is all about the basic introduction about your BCD code. In the very next lecture, we will try to solve some problems on this BCD, which is actually very important. If you stop the BCD here, it is worth nothing, because you have to solve the questions after you know what is a BCD, and we will do it in the next presentation. Basically the addition of the BCD numbers, which involves certain rules. So see you in the next presentation.